Have a number properties question. It is data sufficiency and is a yes/no question, which means we can look for specific examples that either give us a yes or a no answer to try to break this question. And if you're not familiar with that strategy, watch our video on how to approach yes/no data sufficiency questions. We also have a really good quiz on how to walk through that process with some pretty simple examples that illustrate the way to attack these things. Looking at it from a very high level, the first thing I see, and most people probably don't think of it this way, but I think approaching it from this high level is the safest and smartest way to go. This top part here, x plus 1, is always going to be greater than this bottom part here, x minus 3. The top will always be 4 greater than the bottom. For example, if x is 5, the bottom is going to be 2 and the top is going to be 6. So the top is 4 greater than the bottom. And even if we throw negative numbers in, like negative 10 for x, I'll get negative 9 on top and I will get negative 12 on the bottom, negative 13 if we plug negative 10 in. And so I will always have a difference of 4 between the top and the bottom, and the top's always going to be bigger. Now, in order to answer this question, yes, what would I need from my x and x plus 1 and x minus 3? Well, I need the top to be positive and the bottom to be negative to get a negative number, aka a number less than 0. And the reason I need this specific mix is because I know that in order to get a negative number, I need a positive negative. And I can't have this situation because I know the top is greater than the bottom. So it's impossible that the top would be a negative and the bottom would be a positive given the setup that we were originally given here. So I know that we need this situation. And if I look at it, how would this situation exist? Well, the top's going to be positive as long as x is greater than negative 1. Because if I plug negative 1 into the top, I get 0. And if I plug anything bigger than that, I'm increasing the top. And so it's going to be something larger than 0. And anything below that will give me something less than 0. And so x greater than negative 1 guarantees the top will be positive. And a lot of times I focus on what I call break-even points, which is like, when would this top equal 0? Well, it would equal 0 when x is equal to negative 1. So I know that's an important point, and I focus on that. And all numbers above or below this will probably do something consistent, as long as we don't have an x squared situation like we have in statement 2, because things get a little funky in x squared situations or absolute values. So looking at this, I know that the top is guaranteed to be positive based on statement 1, which says x is greater than negative 1. It's also less than 1, and that's going to be affecting the bottom more than the top here. So the bottom is always going to be negative when x is less than 3. So if x is less than 3, it's guaranteed the bottom is negative, because if x were 3, the bottom would be 0. And if x were 2, it would be negative 1. If x were 1, it would be negative 2. And you can kind of see the trend that's going on here. So if x is less than 3 and greater than negative 1, I'm guaranteed to get a positive on top and a negative on the bottom, which is exactly what we'll get given this situation. So statement 1 is sufficient, because if x is less than 1, it's guaranteed that the bottom is going to be negative. And if x is greater than negative 1, it's guaranteed the top is going to be positive. So we have a sufficient answer here. Let's look at statement 2. Statement 2 says x squared is less than 4. Well, this is a little bit tricky, but we can think of it using examples. I know this will break even at plus or minus 2 for x, because plus or minus 2 squared gives us 4. So I know that these are important points. Now, on a number line, if I plug in negative 2 and 2, with an inequality, it's either that all the things in this direction and this direction follow this rule, or else it's everything in between from here to here. And one way to test that is to test 0. So does 0 follow this rule? Yes, 0 squared is 0, and that is less than 4. And so it's a little confusing because it looks like I put an equal sign there. Let's erase that. So 0 is part of this rule, and so 0 is in place. So basically all the numbers from negative 2 to 2 work for the rule in statement 2. Now, is that going to guarantee a positive on top and a negative on the bottom? Well, it's not, because numbers less than -1, so from -1 to -2, don't follow this rule that would guarantee we get a positive number on top. So it is possible for me to get a negative negative. It's also possible if the number fell in here that I would get a positive negative. So this is insufficient because in certain situations, I do get a formula here that's less than 0, and it would answer the question yes. And that would be this situation. And in other situations, I get a no answer, such as if the number falls between -2 and -1, like -1.5. And so it's insufficient because I don't know which of those answers it is, because it depends on which numbers I choose. And this rule has enough flexibility to choose either one. So answer is A, statement 1 on its own is sufficient, and statement 2 is not.